if it's far below what you're supposed to get versus above what you're supposed to get.
But yeah, you're right. If you have small sample sizes, you've got more problems with the linearity or standard normalization.
Yeah.
Because when you have small sample size, you have one or two outliers to add a skew.
Yep. And so we worry most if it's a large deviation from the expected sample size. But in a lot of cases, you don't have a large deviation because to me, and this is just my thinking on it, ReoSoft, most of these sample size calculations really end up calling for larger sample sizes than I would expect based on what people are analyzing. But they do establish a goal, and there's a lot of research behind them. So I'm going to trust their experience in sample size calculations or sample size determinations and say, well, mine is biased because back when I was taking statistics classes, they always said n equal 25 and you're okay. Now they're saying n equal 30. So things change in statistics. So we have to try to meet the sample size goal that ReoSoft says we should have.
And on the sample sizes, one of the things I'm having issues with it, ReoSoft has that default where it says, remember this in Patty's class, she said, if you have no previous data, you assume you're at 50%, half the people are going to answer it one way, half the people are going to answer it the other. But if you've got previous data from the survey, and the data comes in at 10% answer it one way and 90 the other, or vice versa, you can plug that into ReoSoft and your sample size plummets.
Yeah. I
mean, way down.
Yeah. So if you're in a setting where you have that data, that can help you out quite a bit. Yeah. Okay, the next thing is variance. And a lot of the tests we've talked about have requirements for constant variance. And sometimes we don't have constant variance. So if you think about regression, if we plot that regression line, as the independent variable grows larger, we don't want to see the variance around the regression line growing larger. We want to see the observation still being within a certain amount of space around that regression line. So variance is something we look at. Now, we've already seen Levine's test. We saw that with the t-test. And we can actually compute the variance tests on ANOVA. There's one option for, I think on ANOVA they call it homogeneity test. So we can do these tests in a lot of different places. So then we can figure out, do we have constant variance or not? And what we'd be looking at for parametric tests is the measure based on mean, because parametric tests are based on using means in most cases. And for this one, total defects, this is the whole sample. Does it look like we have constant variance or not? What's our p-value?
P-value is greater than 0.05.
Yep, the p-value is what, 0.248?
0.248, so we would reject.
You failed to reject.
Fail to reject. Yep, remember p-value less than alpha, reject. P-value not less than alpha, fail to reject. So we're up here. So this looks like we have constant variance.
Okay.
Now I'm going to show you some graphics. This one is just looking at standardized numbers, and what we what our typical objective is to have about 68% of the observations be within plus or minus 1 standard deviation when we compute z-scores. So if you really are obsessive, you could go in here and you could count how many observations are outside that range and figure out what that percentage is. But we have the test we just looked at that will give us a pretty good indication of what's going on.
Why 68?
It's because that's plus or minus 1 standard deviation, and at the time people were using it, this was pretty much the easiest way to do an estimate. But
So,
now we have the statistics that we can rely on.
okay.
Yeah, at one time we just looked plus or minus 1 standard deviation. That's a nice, easy thing to compute. But things get better with computers. Now here we have nice, normal variance.
Okay.
Right? No, yeah. Things are going a little bit crazy as the value on the x-axis grows larger. Here's an example where we do have what looks like pretty normal variance. Now, granted, well, I'll say this. If you ever run into a situation where every observation is on that line, guess what? People are not going to believe you. They're going to say, "Oh, did you make up your data? Did you forget that there should probably be some variance in the data?" So this looks pretty nice because we see an obvious linear trend to the data, and we see that if we plotted a line, it would probably go pretty close to the middle, and we see that the width of the plot, the scatter plot, doesn't change much as the x value grows larger. Okay, so what to do? First of all, these are most serious if we have small sample sizes, once again, or if we have unequal sample sizes, and that you're probably not going to have the exact same number of people in each group. Even if when you're putting people into groups, you intentionally assign an equal number to each group, you're going to have people drop out of the study. You're going to have people who, when you start looking at their results, you're going to see that they clearly didn't understand the instructions. Or you're going to have people, for example, if you're doing something with undergrad students and you have someone who says that they're 105 years old, and you saw all the participants and none of them looked over 25, and you have to wonder, now, did this person take it seriously? So you may have to pull people out of your sample based on various problems.
Is that ethical?
If it's clear that the person didn't understand the study, then it's acceptable to pull them out. You probably, for your dissertation, you would want to talk with your dissertation chair first. If that person would probably send you to Dr. Brown or me, and we'd talk about it. But if it's clear they didn't understand the directions, it's okay to pull that out.
Or if they made Mickey Mouse on their bubble sheet.
Yeah, yeah. And people do that.
If you included like a statement of acknowledgement saying that these responses are, I submit that the following responses are true and correct and made in good faith, is that something that may add validity to your study, saying that you included something in addition to the directions and explaining the purpose and scope of the study so that they understand the concepts, but then in addition to that, including something that says I'm going to take this seriously and honestly? Would that add any kind of extra validity to your study?
I don't know, and I'm curious if there's research about that, because I could see two possible things happening. potentially maybe 3 possible things happening. The people who are going to take it seriously, they're probably going to take it seriously with or without that. There are some people who might say, oh, okay, they're asking me to mess with the results by including that. Or the ones who wouldn't take it seriously, there are some who wouldn't take it seriously no matter what. So I think that's a great research area. And I'm wondering if someone has done research on that, because
especially if you're including incentives, and someone may say, well, this is the prize that I really want, so I don't know anything about, you know, I'm not active military, but I'm going to sit for this study that's for them because there's a chance I could win $500.
yeah.
You know?
And their responses really wouldn't be valid because, like I said, they're not military. They weren't in the military or retired. So yeah, and so I think it'd be interesting to see if there are some studies about how you can promote the idea of people responding correctly in studies. And I'm guessing there's probably something in psychology on it.
I think I've seen some stuff like surveys I take because I perceive that there's some greater good to them. You know, I don't participate because somebody's going to pay me or give me a token or something. It's just because I feel it's beneficial to, you know, it's important to society that I do this.
And there's one issue that comes up with incentives that I don't know if anyone's ever talked about, but especially when you're talking about students at universities or people where you have a wide mixture of economic positions. I mean, when I was an undergrad and in grad school, hey, $5 extra, that was a good thing. But especially in grad school, my friends who came from other countries, their families were sending them tens of thousands of dollars every year by having different family members come to the U.S. with just under the maximum amount they have to report. And so for them, $5, no, that'd be a waste of my time. And so that can influence who participates in your study and how serious they take it. And so, I'm thinking there probably has to be research on that in psychology, because psychology does so much research that involves students.